Good morning, everyone, and welcome. I am really pleased to be kicking off a couple of different Microsoft presentations that are all going to be happening here in this room this morning. So we're kicking it off with making the most of Azure Active Directory Application Proxy. It's a product that you may have heard about through several of our conversations and even in Alex's keynote this morning as a feature that we've recently gone to GA in with a partnership with Ping Access. So just out of curiosity, how many of you went to either Mark's talk on Monday or Lee and Mary's talk yesterday with that scenario? Okay, awesome. So quite a few of you. So really what we want to cover today, we'll touch on that scenario as well. We'll also be doing a deeper dive on it later this afternoon on how you deploy it. But if you are looking at Ping Access for Azure Active Directory and Application Proxy, once you get Application Proxy, what else can you do with it? How do you make the most of this deployment that you've gone through? So I'm Harshini Jayaram. I'm the Feature Program Manager for Application Proxy over at Microsoft, and I'm here with Tarek.
Good morning, everyone. My name is Tarek Dawoud. I'm a Senior Program Manager with Azure Active Directory. I am in a team called the Customer Success Team that works hand in hand with customers who are deploying Azure Active Directory Premium EMS scenarios, and I'll be providing some of the insights we see from these deployments. I guess let's kick it off with a quick overview. So we're going to talk about the infrastructure overview, the solution overview of actually how Azure Active Directory App Proxy fits into Azure Active Directory's vision overall. Most of you just came from the keynote, so I guess you saw a lot of Alex's overall vision. We're going to talk about the actual authentication flows that Azure Active Directory App Proxy supports, and then we'll highlight some key features of the proxy service that allow you to do cool things, and then some interesting integrations that you can use the application proxy with. So let's get to the overview. So this is kind of the vision that Alex was showing. This is the world as it's becoming today. Lots of compute nodes, as we mentioned, lots of services in the cloud. On-premise is just one piece of it, and lots of people on different devices trying to get to these different services, and including your partners, your customers, your consumers, and different various sources of identities. The Azure AD Application Proxy specifically addresses that arrow going down to on-prem of giving access to all these different identities to on-premises applications that many of them do not support modernizing. Some of them are just a lot of work. And so Azure AD Application Proxy gives you a bit of a boost and a little bit of a nudge in helping you publish those applications, make them available on the internet.
Great. So like Tarek said, Application Proxy helps address the case where now we're all dealing with increasingly mobile workforces, and we need to be able to provide remote access to them. And if we think about past solutions for remote access, we're looking at things like VPNs or placing apps in the DMZ or otherwise opening our network and expensive solutions, maybe things that don't work for all devices, may not work for mobile devices. Well, that's where Application Proxy comes into play. It's bringing you remote access as a service while also extending a lot of the benefits of Azure Active Directory to your on-premises network, bringing a lot of the security that, for example, Alex mentioned earlier today in the keynote to anyone trying to access your on-premises resources. And we will talk about that a little bit more later as well. So let's take a look at how it works. When we're looking at remote access, you're typically looking at a scenario like what you see here. You have your applications on premises, and you have your user who's sitting somewhere outside and needs to get access to them. The way we're going to enable this scenario is through a lightweight agent that we place on the on-premises network called a connector. These connectors need to have line of sight to the application and will handle passing the traffic to the service and to the user. So when you publish these applications with Application Proxy, you create an externally accessible URL. It may be the same as your internal URL, it might be different, and that's another thing we'll get into with the feature highlights. So your user goes to this URL. In this case, it might be appx.contoso.net. When they hit this URL, they are then directed to the application proxy service, and they're asked to authenticate against Azure Active Directory. Application proxy is not doing its own different authentication. It's all still through Azure Active Directory. So once they've passed the authentication challenge with Active Directory, which may include any of the multi-factor authentication or other layers that you choose to place on top, that traffic is passed along to the connector and then on to the applications, and this is the flow that results. So when we think of the benefits of application proxy, they really fall into three main pillars: simplicity, productivity, and protection. There's some details on the slide, but just to highlight a few of them. When we think about simplicity, we're putting the connectors on your on-premises network. They don't need to be in the DMZ because it only uses outbound connections. There's no inbound connections. And we have a lot of protections there. The service also provides many of the benefits you typically think of with the DMZ, such as terminating traffic. So you're not putting anything in the DMZ, and you don't need to update your existing applications to have them work with the connector. When we look at productivity, we're giving more access to your apps from any device and any place. You're helping your users be more productive. And finally, for protection, as I mentioned, there are no inbound connections. You're getting security verification at a cloud scale and all the protection of Azure Active Directory to those users trying to access your on-prem resources remotely. So here are a few different types of applications that are supported by application proxy. So for example, browser-based web applications, whether they're using Windows authentication or forms-based authentication or header-based authentication, and that's where our partnership with Ping Access comes into play and the solution we GA'd last week. We also support rich clients if they're ADAL integrated, or you can publish remote desktop with application proxy and other applications through that. So Tarek has had a lot of experience with customers, and so he also has some examples of these application types that customers have really enjoyed using.
Thank you, Harshini. So to give you guys a few examples of what we're looking at here. So on the first one, I have a customer who's deployed their on-premises Dynamics AX deployment, which they're using for supply management, people placing orders and stuff like that for their resellers. And that system is deployed on-prem. They bought it 2 years ago. It's Windows Server, but they're using the Azure AD application proxy with pre-authentication to give access to it remotely to these resellers. So they're using it not just with Azure AD, but with Azure AD B2B. As an example of the second one, I have a customer who's deployed it with BombGuard. And in this case, they're just using Azure AD application proxy as a reverse proxy to on-premises, and then there's a login form that pops up for BombGuard for their support agents. And then they're using Azure Active Directory's password vaulting capabilities to have it save the password and punch it into the form on top of the published application proxy app. So that's another example. A third example with, for example, rich clients. I have a client who's published on-premises SharePoint, and they're able to still access the on-prem SharePoint through the Azure AD application proxy with Word and Office. These rich clients, they're able to still open all these URLs through the external link that we provide to them. An example of just simple pass-through, where you just use the fact that the proxy eliminates the DMZ for you. I have a client who's using it to publish S2S server calls. So they have a back channel between them and another company where servers authenticate with cert-based auth to other servers with TLS. And they're using the Azure AD application proxy just to avoid putting any of this stuff on the DMZ. So it just tunnels down to on-prem to the servers, and they do TLS with a cert handshake and move on. So these are examples of, creative examples of how you can use this basic infrastructure that we provide for you guys to serve business needs. So we're going to cover now, explain a bit of the mystery of the authentication flows. So the application proxy has two modes. One is pre-authenticated and one is pass-through. We're going to explain here the pre-authenticated flow first. So the way that one works is the user goes to a published URL that you publish. As we mentioned, you get a free URL from us, app-yourcompanyname.msappproxy.net, but you can also give us a SSL cert and you can publish it with whatever name you want. And so end user goes to that. This request is fronted by the app proxy service, the cloud service running in Azure. What it will do is if you set up pre-authentication, it will recognize that and then redirect the user to Azure Active Directory. If the user happens to have already a session, because he's already logged into Office 365 or to some other SaaS app you set up with Azure Active Directory, then they see no authentication. They're fine. They just go redirect it back. Conditionally, you could have put more stringent conditions on this app. You could have said this app should only be accessible from inside the network, should only be accessible from outside the network, should require multi-factor authentication when you hit this application from outside, for example. Based on these conditions, we might go back to the user and re-challenge him for extra stuff. And if the user fulfills the challenge, then what happens is Azure Active Directory gives a token to the application proxy service. The application proxy service will actually replace that with a web session and invoke a call down to on-premises to try and find the application. In this case, the connector, in the KCD scenario, KCD is Kerberos Constrained Delegation, will actually go to Active Directory and authenticate the user on behalf of the user. So actually, you will create the necessary configuration to allow that machine to impersonate users going to that app, and therefore it will just go and acquire a Kerberos ticket on behalf of the user, silently matching the user from the cloud to the user on-prem, and then getting that Kerberos ticket. Then it will submit the Kerberos ticket to the application on-prem and get the content and then stream it back up to the application proxy service, which will send it down to the user. That's kind of, in a nutshell, how the flow works. The other flow we have is the pass-through mode we mentioned, and in this case, there's no authentication to Azure Active Directory or to Active Directory on premises. So the user goes to the URL, they hit the proxy service finds a proper connector, and requests are sent to the app and then streams the content back. If the app publishes a login form, the user sees a login form. If the app is just streaming content, the user sees the content. In this case, it just saves you the cost of maintaining a DMZ. Again, think about the cost of simply people trying to DOS you and DDoS you and all that stuff. A lot of that stuff is fronted by us, and you don't have to worry about it. And we stream the content back to the user. Now, back to Harshini.
Thanks, Tarek. So now that you have a feel for a little bit of the flow of application proxy, let's look at a couple of the feature highlights that you can use. So one thing that Tarek and I both referenced a few times is the ability to use your own domain for even the external URL. So by default, if you come to use application proxy, we have a domain that you can use for these apps that'll look something like your tenant name -msappproxy.net. So for example, myapp1.contoso-msappproxy.net. But of course, when you're having your users access these resources externally, you'd like to be able to have your own domain. And so if you are able to verify a domain in Azure Active Directory and upload an SSL cert for that domain, you can then use whichever domains you verified for these applications. So instead, you could have myapp1.contoso.com. And so this helps a lot with even making sure your users don't need to learn two different URLs, right? Whether they're external or internal, doesn't have to matter to them. It also helps in the case where you have links between applications and you're using the application remotely. The links will continue to work. However, on that note, we know that it's not always possible to use the same URL internally and externally. So in that case, we support body link translation. So for example, let's say we have two applications, and each of them reference an internal link to the other application. So app2.local is pointed to from app1, and app2 points to app1.local. Well, if you've published these applications with application proxy, when you're accessing the app externally, we'll go through the body looking for any URLs that are recognized internal URLs of an application proxy app, and we'll replace that with the corresponding external URL. So in this case, for app1, we're able to recognize that app2.local was an internal URL of a published application and replace it with app2-contoso.msappproxy.net, so all of your links will continue to work. One other feature we wanted to highlight is the ability to create connector groups. So here, this is a different look at that same flow that we had before. So user goes to the browser, goes to the application proxy server, is asked to authenticate against Azure, but really what we've broken down is the connectors that we'd shown you before. So when you create connectors, they'll serve any of the applications that are asked to point to those connectors. But what you can do is group connectors into different groups, and you assign applications to a specific connector group. Any connector within the connector group can serve the content for that application. Now, this gives you a few different benefits. First, you can choose how you want to group these connectors. So for example, if you have applications located in different geographies, you can definitely create different groups based on the location to help drive down the latency for your users. And also, by having connector groups and multiple connectors in that group, you're giving yourself higher availability and resiliency. Since, if one connector, if that machine goes down for any reason, there's still other connectors and your users will have an uninterrupted flow as the traffic continues to go through. So that's kind of a look at connector groups and a few of our highlights. So now that we have application proxy, how do we use this with other products as well? So there are a lot of scenarios this serves by itself, but there are other scenarios that we've had questions about and integrations we want to discuss. So one of them is, and a lot of you went to the talks earlier this week, so you have heard a little bit about application proxy and ping access. So as we've discussed, this is extending the reach of application proxy to apps that use headers for authentication. And the way this changes our flow is that you install ping access on premises, and the flow will take the traffic through ping access to create those headers and send it on to the application. So you get the flow here. Again, we're not spending tons of time here because if you want to learn how to deploy the scenario and you want a really in-depth walkthrough, I highly recommend you come to our masterclass later this afternoon at 4:20. We'll be going through this in a ton of depth and how you actually deploy the scenario end to end. Another integration is with Microsoft Work Folders. So for those of you not familiar with it, it's basically a relatively new Windows Server role that allows you to to have file sharing in a way that doesn't get tied back to the server itself. And so this is something that we now can integrate with application proxy. We got a lot of questions about, how do we publish files through application proxy? Well, this is a new story that helps you do so. And also, if you know, both for the previous scenario and here, there are documentation links at the top if you do want to learn more. And finally, just one other scenario to call out is an integration with remote desktop. So you can publish remote desktop with application proxy. And in this case, why would you do that? Well, with application proxy, you're, again, bringing all the benefits of Azure Active Directory to remote desktop. You're reducing your surface area for attacks, and it's just, again, bringing lots of protection to that story. So that's kind of a quick overview of application proxy. If you want to learn more about it, you can see the link there, so aka.ms/application proxy. If you want to get to the documentation about our scenario with ping access and that integration, aka.ms/ping access application proxy. And if you want to reach out to us directly on the team, you can also email us at aadapfeedback@microsoft.com. And here's a list, again, of some of the other talks that we have going on, and I've highlighted the masterclass that I kept mentioning throughout this so that you're able to find it. So thank you very much. I think we have just 1 or 2 minutes for questions, maybe? A couple minutes for questions.
Are the connectors agents that are installed on each server?
So you do install a connector on different servers. You can choose how many you want. We are in the process of coming up with some capacity guidelines and recommendations for how many connectors you need based on how many requests you expect to see or how many users, but it does not need to be one connector per one server.
I guess my question was more like, are you using a centralized proxy server inside, or are you using an agent that runs on each server?
It's the latter. So it's an agent running on each server, and you can install the agents on other roles, same on the application role, on the AD Connect role, and so on. Up front.
You mentioned that for the connectors, there's no inbound connection or inbound traffic coming in. But if the user is initiating the initial request from outside the corporate network, then how do you reach the connector if there's no inbound connection?
How indeed. So it's no secret sauce. The connector uses technology in Azure called Service Bus, which basically allows an on-prem component of any type to reach out to Azure as an infrastructure and maintain a 443 connection. So now Azure is keeping that 443 connection. It's outbound, so Azure is not punching into your firewall to get through. You're actually reaching out to it like you're hitting Google or YouTube, basically. And it keeps that connection alive. And then what happens when the proxy service gets a request for that URL, it finds that specific connection. It's registered with your tenant specifically, and it streams the content down to the connector and sends requests and commands to the connector and says, find this server and submit these requests to the server. Yes. So between the connector and the Azure infrastructure. Follow-up question here.
Hi, I know this wasn't a deep dive by any stretch, but you kind of glossed over the whole remote desktop aspect. Could you just a little bit more color commentary to that?
So remote desktop, if you have IE or Edge, you can get single sign-on. So Azure AD will give a session to the user. That session will be transmitted to the RDP service so that the user will actually not have to authenticate when they hit this machine that they're actually hitting on premises. I think with the other ones, you'll get actual pop-up.
Right, so we have a couple of different flows depending on the clients that you're using. And so I can actually just find you afterwards and we can diagram out a bit and go into more depth if you'd like.
Just so if I see if I got this right, you seem to be terminating SSL on your end inside Azure AD, and then you have a separate SSL connection, so the passwords are flowing in clear on your service in AD.
In this flow, there are no passwords except in the one where I said there's a form-based auth, and you actually expose that. But in all the other flows, there's a token between Azure AD and the proxy service.
Because you're authenticating with the Azure AD before you establish the connection.
Yeah, and that token, after it's consumed by the proxy service, is not sent down in the call.
Right.
The call has a web session in a separate.
Got it. In the case where you're doing auth through ping or anything else, then the password is flowing in. Clear.
In the case of ping, ping access does its own OIDC call back to Azure AD and gets a token, and in that token it gets all the necessary claims, and then it creates the headers it needs. There are no the user password is not really passed except in the form-based auth scenario, which is it's passed over HTTPS.
Okay, thanks.
Did you want to add something? No, we're running out of time. So, so thank you all very much. I guess we will conclude, and for those of you who are interested in continuing the conversation, we'll cover the ping access scenario in the masterclass later this afternoon. Thank you all.